Good morning, guys. Welcome to today's lesson, April 8th, another review lesson. We're going to take a look at some prior modules and some questions in that. First, let's just talk quickly. So, you've been hearing that the Regents exam is canceled in June. That is absolutely true. Okay, but what I can tell you is do not take your foot off the pedal. We have to continue to do our daily lessons, our Delta Maths, because we don't know what that means. The Regents exam being canceled, it's not like it's a guarantee where you'll move on to Algebra 2 next year, no doubt. Okay, you might have to make sure you pass the course. There might be a final exam in its place, in the Regents exam's place. There might be some final exam that's like a Regents that you'll have to do well on to move on to Algebra 2. Okay, we really, at this point, we teachers, we don't know. All right, we don't know what the next steps are. So please make sure you're still taking the lessons seriously every single day and you're completing your Delta Math. It's not much. Make sure you're getting that done. All right, I'm being totally honest with you. I don't know what's coming next. So make sure you take everything seriously. At this point, we don't know. In addition to that, tomorrow you will be in Module 5. Okay, that's our final module. So at this point, you should copy over Module 5. It's just a blank section, or make your own Module 5 section, but that's where I want the lessons to be. Today's lesson is still Module 4. All right, but after this, all lessons from here on out are going to be Module 5. So you can either copy over the Module 5 section, or you can just add your own section, but that's essentially where your marking period 4 grade is going to come from. I need to see that your lessons are in Module 5. And as always, please make sure you're not just copying over the answer key. All right, like this right here. This shouldn't be necessarily in your folder. Okay, my writing and all that. That's not your goal for the day. Remember what your goal is. Copy it over. Do now on your own. Go back and check it. Use the video to fill in all of your notes, okay, that you write in. Then on your own, do the extra problems that I leave for you, and then use the answer key to check your work. All right, so you might see some check marks like, oh, okay, great, I got this one right, good. All right, this one I didn't. What do I have to correct? Maybe I have to fix, whatever. But you're just making the corrections. All right, just making sure you have the correct work. And as always, if you have questions, please let me know. All right, let me know and remind, okay, and we'll straighten anything out. So for today, we're going to jump around a little bit. Okay, it's all review. Look at the aim. What do we need to master from prior modules? All right. You'll try example 1 on your own, okay, and we're going to do example 2 together right now. Okay, so which sequence of transformations will map triangle ABC onto triangle ABC prime? There's 2 transformations that take place here. Pause the video and just in a couple words think about what 2 transformations they would be. Okay, it's a rotation and it is a dilation. So hopefully you had that, but remember when we say that we have to be more specific. By the way, I don't know if I already mentioned this, I took away all the answer choices. All right, we have to actually write it out and state it, because if we can do that, we can definitely pick the correct multiple choice answer. So it's a rotation. Let's think about what do we have to say for a rotation. We have to say what direction. So how would I get from A to A prime, for example? A to A prime. What direction is that? That is counterclockwise. All right, how many degrees? So we can check that, remember. And typically, guys, the center is the origin, so this point here. So if I was going to connect A to the origin and then to A prime, what type of angle would that make? Hopefully you see that that's a 90-degree angle. All right, so it should be 90 degrees, but let's just make sure we check that. So let's connect B also, B to the origin to B prime. Yep, that looks like a 90-degree angle. And then C to the origin to C prime. And we can check, yes. So 90 degrees. About the origin. When in doubt, it's going to be the origin. It'll be clear if it's some other point. All right, followed by Now a dilation, we need to include once again the center, which is just the origin, what it rotated, what it dilated about, what point. It's going to be the origin again. We just have to figure out what the scale factor is. Now that's a little bit tough to see. You might be able to approximate what it is, but we should be able to get an exact measure here. So if I was going to count from B to A, it's a movement of 1, and then 1, 2, 3, 4. And then if I was going to do B prime to A prime, it would have rotated, so it's going to be a different, the movement's going to be sort of in a different direction, but remember from B to A it was 1 and 4. From B prime to A prime, it's 2 and 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's double the movement. That tells you that your scale factor is 2. So a dilation with scale factor centered at the origin. This is something I really wanted to take a look at because we might be able to say right away a rotation and a dilation, but we can't expand on it. We need to make sure we can do that. So a rotation, what direction do we go? Go clockwise or counterclockwise? How many degrees? And about what point? Okay, a dilation, what's the scale factor? Is it 2? Is it 3? Is it 1/2 if it got smaller or something like that? And what is it centered at? So be careful. Be specific. All right, and that's that. So once again, that was multiple choice. Let's also take a look at example 3 here. What transformation would result in the perimeter of the triangle being different from the perimeter of its image? So how would the perimeter be different? Hopefully you're thinking a dilation took place. If the perimeter is different, right? Even look at these two triangles. A dilation took place, right? The perimeters are different. The side lengths are bigger or smaller, whatever. Adding up all the sides is going to result differently when a dilation takes place. So which one of these answer choices shows a dilation? All right, I'm going to give you the answer. It would actually be choice 3. Why? Because what's happening to the coordinates in choice 3? They're being multiplied, each of them, x and y, they're being multiplied by 4. Whenever you multiply the coordinates, a dilation takes place. So in choice 1, they flipped x and y. That's not multiplying anything. Okay. In choice 2, they negated the y value. All right, multiplying something by 1 or -1 is not going to change its size necessarily. In choice 4, there's addition and subtraction. So anytime there's multiplying of coordinates, a dilation takes place. And now it doesn't have to be x and y. It could have been just x. Like they could have said xy becomes, let's say, 2xy or something like that. So just x got multiplied or just y got multiplied. That would still be a dilation and the perimeter would change. All right, example 4 you'll try on your own. Example 5 you'll try on your own. Nice review of trig. And example 6, I'll start with you. Line L is mapped onto line M by a dilation centered at the origin with a scale factor of 2. The equation is as follows, right? 3x minus y equals 4. Determine and state the equation, an equation for line M. And remember, it's also centered at the origin. So I highly suggest you try to solve this one on your own. This is in the dilation equations lesson. All right, dilation equations. But what we would do, we would check to see if the origin is a point on the line. If it was, this would be our answer. We'd be done. The line doesn't change. However, the origin is not on this line. It's a point off the line. So what that means is we have to multiply the y-intercept by the scale factor. Now, we don't know what the y-intercept is. Okay, we don't know what the y-intercept is because it's not in slope-intercept form. That whole y equals mx plus b, it's not in that form. So we have to solve for y, get y all by itself. We bring down a negative y here is equal to negative 3x plus 4. There's really a negative 1 in front here. So we're dividing out negative 1, which just changes all the signs. And we get y is equal to 3x minus 4. So now we can see, right? We could see the slope. We could see the y-intercept. All right, but at the end of the day, when something gets dilated, you take that y-intercept and you multiply it by the scale factor. Scale factor, checking the problem, is 2. So our final answer would be y equals 3x minus 8. Same slope of 3 and a different y-intercept. So you'll try the rest of these on your own. Once again, make sure you're taking these seriously. We don't know what the canceled regions means. Okay, we don't know what that means for us. All right, there might be a final exam. Let's take it seriously. Make sure you're doing the right thing every single day. Daily lesson, weekly Delta Math. Delta Math is due tomorrow. All right, and Module 5 tomorrow. So this lesson goes in Module 4 today. Everything from here on out, you either make your own Module 5 folder or just copy it over. All right, guys. If you have any questions, let me know and remind. Have a wonderful rest of your day, and I'll see you mañana.